Hello and welcome to this walkthrough. Today I'm going to be looking at the case called DOTS, which was part of the Road to Las Vegas 2026. I'm relatively new to this. This was my third live participation in a Road to Las Vegas event. I'm pleased to say I managed to qualify based off this. So I didn't get full marks. In fact, I don't know if anybody did, but I've now gone through afterwards, looked at the answers and worked out where I went wrong and also where I went right. So I'm going to talk you through. I'll generally be mirroring the approach I took during the live solve, but obviously making it a little bit tidier and dealing with edge cases, for example, on I think level 5 where I missed a few marks, which I'll explain when I get to it. So yeah, hopefully this is helpful. Feel free to, I find it helpful actually to watch these on 1.5 speed because I talk slower in reality than I do in my head. So when I watch these back, you can speed them up and still follow what's going on. As I said, I've put a few notes to make this as efficient as possible because otherwise these videos can balloon to be quite long if I don't do that, and yeah, that's just time wasted. So you will see I've already set up my data tables and a few notes. Just to say, so quick introduction to the case. It's based on a game which has various different names depending where you are in the world, but it's basically a thing where you would draw a bunch of dots on paper, and between you and a partner you would take it in turns to draw lines between the dots, and when you finished off a square you claim that square and then you took another go. And quite a simple game, but obviously you can add lots of complexity when you turn it into an Excel case. So that's what we're going to be working through. Let's start the timer. This shouldn't, I don't think it'll take more than half an hour, having now seen what's coming up. So let's get started. So we'll start on level 1. So how many squares are there in a dotted grid? So basically if we have 4 sets of lines and 3, then the squares are what's inside that. So it's basically we take the height and we take 1 away from that, so we get 2, and we take the width and we take 1 away from that, so we get 2 actual rows of squares and 3 columns of squares. And if we just take the product of those numbers, we get 6, which is our answer. And when we fill that down, we then can grab our real answers, paste them over here. We see that those are all correct. So then we go on to question 2, which builds on that similar one. Now says, well, based on a certain size of grid, how many lines are there? So we actually start with the same logic as before. So we take the height and width and we minus 1. But then what we do is we kind of invert it. So if there are, in this case, if the width is, there's 4. So for each of the columns, there are actually 3 lines in between. But then how many rows of that is the original height? So we basically take this number and multiply it by the original height, and we take this number and multiply it by the original width, and we get 8 and 9, and when we sum those together we get the total number of lines. So in this case that's 17. So I'm just going to try and fill that down nice and quickly, and we'll just grab all of those answers and paste them over here. You'll notice I'm trying to use my keyboard as much as possible and avoid using the mouse. Now this question gave us kind of odd wording. It said basically imagine each dot represents a location, 1 1 1 2 1 3, and the line represents the average of those two. I think I got quite lucky here, and I realized pretty almost straight away that actually, and this is where I need to import my lambdas, that actually the row number and the column number effectively provide us the answer here. So if we take the row number of this cell and the column number of this cell, this reference, we get 5 and 6, which is just those numbers doubled. So if we just divide these by 2, we actually get the answer. So that probably saved me a lot of time in the live case that I kind of had not any real skill, just a bit of luck that I kind of saw that pattern fairly quickly and therefore wasn't playing around with lots of other calculations. So that's level 3 done. Then level 4, we now start thinking about the lines adjacent to a square. So we're given a square and we're asked to say how many lines are there next to it. So this is the first one where I'm going to go into my data table. What we need to do is we actually need to go to our board, and I'm going to make a copy of this. And I'm going to rename this one just board, and we'll make this the one we work on. Always make a copy of these just in case anything goes wrong with the original and we don't want to change it. So we need to identify each of these colored cells. So I'm going to use OA robot here, and there's a command there called go to similar background color. which when I press enter selects all the cells that are red, including the one that has the original name. I'm just going to put an R in there for red, control enter, and that fills all of them. And then I go to one of the blue cells, do the same thing again, and this time put a B for blue and fill those in. So we've now got R's and B's in our board. So I go to level 4. What we want to do is we want to look up this cell and we want to look up the adjacent cells next to it. So the way I did this in the live case, which is probably not the most neatest now that I think about, was to use an indirect. So reference the name of the sheet, which we've called board, reference this cell, and that's going to return nothing because there isn't actually anything in that cell. But if I wrap that inside an offset, and then I offset by -1 row down, -1 column across, and then 3 cells for height and size, we get to see the actual cells themselves. So we now see this is our middle cell, E7, and we've got a blue to the right and a red below it. So now we just want to count how many of each. So we want R and B, so we're just going to say the sum of counting how many times this range equals that value. And we get 1, and we'll do the same again, summing of this range equaling that value. And we get 1 and 1, and then we just concatenate that all together. So we're going to concat, and it wants us to take the red number, then the red letter, then the blue number, then the blue letter. And we get R, 1R, 1B, which if I reference that as my answer, and we go back to the case, we see that on level 4 we've got all of those correct. Then level 5, really starting to ramp up, we're given a cell and a color, and we're basically being told to now imagine that we're placing a line in between, we're given a cell which is actually a line address, and we're imagine we're placing the line, and we're then working out how many lines around the 2 cells that we have we're between, because obviously every line is between 2 cells. So go to level 5. So again, I started off with something similar to before, but then this did catch me out and I lost a few marks here. So I said the indirect, start off with the indirect of the board sheet and cell B1, and then wrapped that. This time we need to look a bit further. So my offset, I'm going to go 2 cells back, 2 cells up, and then bring through 5 cells in each height and weight, because I want to get a higher range. Because if there's 2 possibilities, if I'm putting in a line, I need to look at the 2 cells left and right, but if I'm putting in one that's going across, I need to look at the 2 cells above and below. So we needed to take that into account. So the way I did that was I started by grabbing the row number of the reference, and I then said, is it odd? Because if it's odd, which it is in this case, where in F5 we are, if I try and find the example, so in F5 we're going up and down, so we want the cell to the left and to the right. So what I did there was I said, if this is true, then I want this range, otherwise I want this range. Okay, and it doesn't like that. I did something wrong there. Let's try that again. So if that is true, give me these cells, otherwise give me these cells. And then this shape I'm always dealing with is the same. I just put that in a 2 col. But we also need to include the fact that we've now added red to this middle cell. So what I said was, let's restack the left of this. So we get R for red and what we had before. And now we're just going to have something similar to what we had on the last level, where we're saying we're going to sum wherever this equals that. And we'll do the same for this second range, sum wherever this equals that. And then we do our same concat trick as before. So we're concatenating the red number, then R, then the blue number, then B. And that gives us 2R2B. And hopefully when we reference that, we'll go back to the case. And we see this, and I got this wrong in the live case. So there's 2 which go out of range. So if we go to 85, as an example, we get a reference error there because we're completely out of range. So what I'm going to do here is I'm going to try a slightly different approach, where I'm going to do kind of each of these offsets indirectly, or not indirectly, but separately. So we then, if there are any errors, we're not worried about it. So I need to create a sequence of 5 that starts at -2, and a sequence of 5 going across starting at -2. And then this time I'm going to point my offsets to these references. So I'm just going to say offset by this, and let's fix that based on the column, and then the column based on this fixed by row. And I should also fix this cell reference. And now when I drag this down and follow, our ones that are out of range return a error, and we're getting a reference error for those two questions. But I can get rid of these errors here by going to my to col and just using the letter using 3, and it returns them all. If I go back to the case, we've now got those all correct. Okay, level 6. So level 6 is where we now start with the original game board, and we get given a bunch of additional cells that get lines that get filled in, and ultimately the question is saying determine the cell of addresses that will be surrounded by 4 tiles at the end of the game. So if we take our game board and we add in the lines, how many full squares will we have, or which ones will be full squares, and then some information from that. So what we need to do is we need to find out which are all the squares. So I did this in our game board. It's a 10 by 10 grid, but that actually means there's only 9 squares. So there's 9 by 9, there's 81 squares. So I need the addresses of those. So what I did was did a sequence of 9 starting at row 3 going up in 2s. Did the same thing going across, so sequence across of 9 starting at 3 going up in 2s. And then I said, right, give me the address of these row numbers and these column numbers using relative referencing, and I then just wrap those in a to col to get all of my addresses, and I'm going to name that range as squares. So these are the squares where we can place something. So now if I go to level 6, I'm going to say equals squares. So these are all the squares we could possibly have, and I'll just place those as values now. We also need to know all the lines that are already in place. If I go to my board, I'm now going to use another lambda. I'm going to use my address book lambda to grab all of this, and that's going to give me all of the cells with anything in and what's in them. So I'm going to call this the contents, and I'm going to call this the refs, and I'm going to select all of that, Control Shift F3 to create the names from the selection. So I've got content and ref, so I know what is what. And what I want to know is I want to filter the references where the contents either equal R or the contents equal B. And that gives me all the lines that existed at the start of the game. I need to know the new lines, so I'm going to text split B1 based on the semicolon. So that's all the ones we've added. And I want to just combine those together into a single list. So I'll combine those using VStack. So those are all the lines that exist by the end of the game. I now need to look up each of these squares and look up the adjacent cells and see if they're in this list. So for this, I'm going to use an offset. So we're going to look at each cell above and below the existing cell where we're starting off with. So in one case, we're going to have an offset of 1 row and no columns, then the opposite, and then the same in the other direction. And what I want to do here is I'm going to use a lambda called offset cell address, where we take that cell reference, we take our row offsets, which we'll put in there, and our column offsets, put in there, and that's going to return all of the cells that are around this one, so above, below, left, right. And then we want to know whether these exist, so these cells, whether they exist in this list. Okay, and if we get a number, that means they are. So in this case, 3 of them do, but 1 of them doesn't. So I'm then going to turn those to 1s and 0s, and I'm going to sum those. And I want to know when those equal 4, because when there's 4, that means all of the lines around those squares have been filled in. So if I just fill that down, and then I want to know, I want to basically say sum where this range equals 4. Actually, no, what I need to do is I need to filter this range where that range equals 4. And we get 3 cells, and then we want the row number of those cells, and then we want to sum those row numbers, which gives us 31. And those hopefully are good. How are we doing on time? 30 minutes gone. Okay. So moving on to level 7, which I didn't get onto in the real case. So I got all the way up to level 6, made a few mistakes on level 5, and then the other points I dropped are on the bonuses. But let's do level 7 first. So level 7 basically now gives us a game happening. So we're given all the moves in order, and at the end we have to work out how many cells each person got. And these numbers should always add up to 81 because there are 81 squares and every square gets filled in because we eventually draw every single line. So let's start off by working out, making sure we know how many turns there are. We're going to start if we get told that the red player always goes first. And what we're going to do is we're going to track this by every single square. So I'm going to return my squares list. I'm going to copy that as values only. I'm going to copy it again. And then I'm going to paste it across here as transpose. So those are all the cells. And then what I'm also going to do, just to make life a little bit easier for visual, is just going to shrink all of those. Because even then we can't fit them all in, but never mind. And we also need to know the lines as they appear in order. So this is our text split of B1 on our semicolon. What we need to do is we need to work out how many. We need to use a similar formula to what we had before, which was this one. So counting how many lines have we got around the cell. So what I'm going to do is I'm going to copy this, but so the references don't all need to change. I'm going to change the offsets to absolute values using F9. So selecting this F9. And now if I copy this over to level 7, starting here, and I'm looking up the cell address, which is that, and I'm going to fix the row, and I'm looking it up in this range here, and I'm just going to release that last $sign. So as we go down, that range gets bigger. So we're basically saying in this set of range, how many cells around that cell have been filled in. In fact, I'm just going to move that one row down. So that works. And then what I'm going to do is I'm going to fill that to the right, and to start off there won't be any, but if I now fill this down, and will I be able to do this in a nice easy way? Let's fill that one down, and then if I do this, I should be able to fill that whole thing in one go. And there's quite a lot of work going on there, and something's gone wrong. I must have not done missed one of my cell, because my cell reference is now pointing at the wrong row. So let's change that to L6. Let's fill that to the right and then fill it down. We should start to see some numbers appear there, which we do. And just to help with the visualization, I'm going to quickly turn on conditional formatting so we can see this is what's happening. So as each line is getting added, more and more of the lines are in full, and by the end every single cell has been completed. So we've got all 4s at the end. So now we need to know whether the numbers changed between each turn. So what we're going to do is we're going to sum how many of these are actually no, what I want to do, I no longer want, no, I need to know if these are equal to 4. So sum, so let's add this, minus equals 4. So we just want to know when these are completed. So fill that to the right and then fill that down, and we'll see some of these lines disappear. Now we only get a 1 or 0 when they actually get completed. So most of them don't get completed until the end. And then I can use this trick to say, right, we'll take the sum of the current go and we'll minus it from the sum of the previous go. And that tells us how many squares were completed. So when I fill that down, and for some reason it doesn't go all the way to the bottom, I notice this, we find that we don't hit our first one until row 58, which is what the example says. So that's the first time that a cell gets completed. So now we just need to account for whose turn it is and how many scores they've got. So if on the previous go this was greater than 0, then the current player carries on. Otherwise, we're going to switch the previous player based on if it was red. If it was red, then it becomes blue. And if it was blue, it becomes red. We close that off, fill that down. And then what we need to do is we need to track the scores. So how many have they scored? So what we will say is if this fixed on the column equals that, and we'll fix that on the row. Then give us the finishes, which is basically also the score, otherwise return 0. And the finishes needs to stay locked on the column as well. So then we drag that over, go all the way to the bottom, fill that down, and we don't start scoring well until the end, and then we start getting some scores. And then we want to sum those ranges, 47 and 34, which is looking good. And so our final answer, we're going to concatenate. We take the number, then R, then the next number, then B, and I'm going to put that in here. And I suspect this will take a little bit of a while because it's got quite a few things to calculations to make. And then we'll just check our answers, and they are all correct. And what I'll do, just to speed things up, I'm going to copy and paste those as values only, and we'll just clear out our data table for now. How are we doing for time? So 90 minutes, we've done the main level. So let's go on to the bonuses. So in a 10 by 10 grid, how many lines can be drawn if the center 4 by 4 section of dots is removed? It took me a while to visualize this. So we've got the whole thing, and it says if we take the center 4 by 4 dots out, so if I just color these in. So what I then did was I went to level 2 and I said, right, well, if we had a 10 by 10, we have 180 lines. Okay, if we had a 4 by 4, we have 24. But we also know that if we have this 4 by 4, then we also lose all the lines kind of around it that separate that 4 by 4 from the rest. And that's 1, 2, 3, that's 4 lines in each. So that's 16 in total. So our number is going to be 180 minus 24, so the 4 by 4 minus the 16 that join it to the rest. How many squares on the game board have only one adjacent line filled in them? So I'm going to use level 4, and I'm going to copy this, and I'm going to read the question very carefully to make sure I'm understanding it. Oh, I've got a crash in here. Let's see. Oh, it does crash. How many squares on the game board have only one adjacent line filled in? So basically what we want to know now is we don't want to do this based on those examples. We want to get all of the squares. And again, we'll copy and paste those values on. And then for each square, we want to know the sum of how many squares they have. So we'll just sum this here. And we'll actually say we want to know if it's equal to 1. Is it just equal to 1 or more than 1? How many squares have only 1? So yeah. So we'll say that equals 1. Okay, and then we'll data table this based on the cell rather than the question number. Oh, something's gone wrong there. It's returning some of that. Let me try that again. Alt DT. So the column input cell is this. There we go. And then if I select that range, we get 27 ones. So there's 27 cells where that's the case. And on the game board, how many dots have at least one red line attached to them? So I'm going to use the same thing before. So this time we want at least 1. So we want to know whether that is greater than 1. So this time we're going to say sum that. Oh, so this, well, that doesn't even need to be the sum. It just needs to be I5 is greater than 0. And this time we get 55. Is that correct? Is it on how many dots have at least one red line attached to them? I'm going to go 55. No, I've got that wrong. So what have I done there? How many on the game board? Oh, it's dot. Okay, I know what I've done wrong here. Yeah. Okay. So this time we're looking at dots rather than squares. So we go to our board. We're going to change our here. So our dots, we actually have 10 by 10. And we start at row 2, and then we have 10 starting at row 2, and these are all our dots. And then if we go to level 4 and replace those in here, and that may well have already done the trick. So we get 46. So for that dot in B2, so let's try B2 here. In B2, we have 1 dot, which is red. Okay, let's try. Is 46 the correct answer? No, something else is going wrong here. I might temporarily just quickly pause the video because I don't want to waste too much more time and then come back to it, because I definitely, yeah, let's just quickly pause the video. And we're back. So I think I know what happened. The data table isn't big enough. So we just delete that out. Select this whole thing, Alt-DT, select our column input cell based on B1. And then our sum wasn't looking at the entire range. So we get 59, which I know is correct. So, phew. Literally, as soon as I paused it, I looked at the thing. I was like, oh, yeah, it's because of that, the data table. Right. In level 5, what is the sum of the game numbers where at the end of the turn, the player drawing the line still has fewer lines? So we're going to go to level 5. We're going to copy our game scores over here. We're also going to go to the case and grab who the players were, or what color the player was, and put that here. And then what we want to know is the 2 scores. So the R score is simply the left of this. That's not a dynamic array, so that, and we need to times it by 1 to turn it into a number. The blue player is the 3rd character, so we'll take the mid of that 3rd character, we'll know 1 times it by 1 to turn it into a number. And then what we're going to say, if the left of this equals B, so if the blue player was the player, we want to know whether the blue player got more than them, so how many there was a difference. Otherwise, the other way around. How have I got? If left, oh, didn't close my brackets on the left. Still saying I've got a problem. Oh, I didn't even put it inside an if function. So for left of that, then we get the difference, and we want to know the game numbers where that's negative. So we'll say that is less than 0. Give us 1s and 0s, or not, trues and false. Let's wrap that in a minus minus. And then if we multiply that range by the game numbers and then sum that up, so the game numbers where that was true, we get 443, which will go up to the top. 443. And then example 7, final bonus. According to level 7 rules, if a 3rd player, green, joined in and the order for switching turns went red, blue, green, how many squares would each player fill? So luckily, the way I've built this actually would have been quite straightforward if I'd got to this point. So we're going to add a green player. And what we're going to do is our rules for switching. Red goes to blue. Just double check this. Red goes to blue, blue goes to green, and green goes to red. So red goes to blue, blue goes to green, and green goes to red. And then we'll just fill that down. And we'll fill this cell across to count the number of green scores. And we'll drag that across. And then here we'll just add that we're also going to concatenate the green score and the green letter. And we get 25 red, 9 blue, 47 green. And if we paste that in, we get the correct answer. And we'll go to our clock and we'll stop it. So 27 minutes. So in theory, doable in under half an hour. But no way I could have done that. Like I said, I got to level 6, saw that I was going to run out of time, so then attempted the bonuses. I think I got bonus 1 and bonus 4 correct, but I didn't get bonus 2 or 3 correct, and then I didn't have time for bonus 5. Well, because I hadn't done level 7, there's no point in being able to do bonus 7. And I did quickly look to see if it was possible to just throw some guesses in, but the numbers are too random for that to be the case. So yeah, really fun case. Although a very simple concept, I really enjoyed that. And as I said, the first time, only my 3rd time trying Road to Las Vegas, third time trying it, first time qualifying, first time I really came away from the case going, yeah, I think I did as well as I could. And yeah, so very, very happy with the result. Hope you find that helpful. If you haven't, that's fine, because I find it helpful to do this process anyway. So, and that's the main reason I'm doing it. So thank you very much for watching.